This is lesson 1-3 on factorable quadratic equations. So when we talk about a quadratic equation, before now we've been talking about linear equations. Remember, that's an equation where the power of each variable term is always 1. In a quadratic equation, unlike linear equations, we now allow powers 1 and 2 for our variable terms. But similar to our linear equations, we're still not going to see any square roots or variables in the denominator, nothing like that. In this section, we're talking about, in particular, factorable quadratic equations. What we mean by that is that we can write these quadratic equations as the as the product of two simple binomials. Binomials, if you recall, are when we have two numbers, binomial. So for example, x plus 3 is a binomial. 3x minus 7, that's a binomial. So if we can write a quadratic as the product of two binomials, that's what we mean when we say that it's factorable. Alright, now let's consider this first example. Solve by factoring. So we're going to see two different types of examples, two different types of problems in this chapter, in this unit, where we're working with quadratic equations. Here we're specifically told to factor this. So factoring is what we should always try. Out in the wild, we're not necessarily going to be told what technique to use when we come across a quadratic equation to solve. I recommend always trying to factor. If it's going to work, it's going to be the quickest way to do it. It unfortunately does not always work easily, though. So this isn't something that you can completely rely on, but it's nice enough that I would recommend always at least trying it. So we went to solve by factoring, so I'm going to go ahead and copy the problem. Again, x squared plus 10x plus 21 equals 0. Okay, so when we are factoring quadratic, we need to first look at the sign of our constant term. Here we notice that it is positive. What that means is we want to find two numbers who, first of all, their product is 21, and since this is positive, we want their sum to be 10. So two numbers whose product is 21, their sum is 10, 3 and 7 seem to fit the bill just fine. So that means that we can factor this as x plus 3 times x plus 7. If you're ever unsure if you've done it correctly, FOIL it out again. Remember first, outer, inner, last. Hopefully remember that from one of our high school algebra classes. If we check things quickly, sure enough, when we multiply these two binomials together, we get x squared plus 10x plus 21 equals 0. Now the point of factoring, one of the nice things about our real numbers is that if the product of two numbers equals 0, that can only happen if one of the numbers individually equals 0. So the only way that x plus 3 times x plus 7 can equal 0 is if either x plus 3 equals 0 or x plus 7 equals 0. If this is the case, then we see that x is going to be negative 3. If this is the case, we see that x is going to be negative 7. So our final answers are x equals negative 7 and negative 3. Alright, here's another example. Solve by factoring x squared plus 4x minus 32. Now you're going to notice all the problems that I've given you for our practicing for our drill. I always make this coefficient, this is what we call the leading coefficient, the coefficient of the highest power of our variable. I've always made it 1. That is not always going to be the case. We are not always going to have a leading coefficient of 1 in general. For this class, for our quiz, yes, it will always be 1. But out in the world in general, not necessarily the case. What I recommend doing is if you do run into a problem where you don't have a leading coefficient of 1, try to factor out that number. Frequently, if you do that, that's going to reduce the problem to something easier to handle, but not always. Again, factoring is not always going to work, but I always recommend at least trying it, because if it does work, it makes life very easy for us. Okay, so here we're going to do the same thing as in the previous example. So we have x squared plus 4x minus 32 equals 0. So notice now the sign of our constant is negative. What this means is we now want to find two numbers whose product is 32. That stays the same. But now we want their difference, not their sum, their difference to be 4. The reason we know we want the difference is because this is negative. So two numbers, product is 32, their difference is 4. 8 and 4 seem to fit the bill. So I'm going to write x, 8, x, and 4. I'm not going to put in their connecting sign quite yet. When we have a negative sign here, we are going to have different signs here. In our previous example where we had a positive here, these two signs will always be the same. They're going to be the exact same sign as this right here. Here, it's a negative. These two signs are going to be different. We want the bigger number to have the same sign as our linear term. So here we're going to want the bigger number to be positive. So it's going to be x plus 8. And we want the smaller number to have the opposite sign. So x minus 4. So just like before, in order for the product of two numbers to be 0, one of the two numbers individually must be 0. So either x plus 8 equals 0 or x minus 4 equals 0. So for that to occur, either x is negative 8 or x equals 4. So our two solutions then are x equals negative 8 or 4. All right, let's consider an application problem. We haven't considered one of those yet. So we've got a little word problem here. Suppose a rectangular garden is 3 meters longer than it is wide. How much decorative fencing is needed to enclose the garden if its area is 54 square meters? Now, I know many students kind of have a natural aversion to word problems. Sometimes we see them and just start freaking out or hyperventilating or something. Don't worry about that. Remember, for this class, we're only going to see these in a situation where we don't have a strict time constraint like we will for the drill problems. So don't freak out. Just keep your cool. Think through it. You're going to be just fine. Hopefully, this particular one we're not too worried about. I'm fairly certain that we've seen a problem just like this before. When in doubt, if you're looking at a problem and you're not sure what to do, draw a picture. You really would be surprised how frequently that helps us see what's going on with the problem. So here we're working with a rectangular garden, so let's draw a rectangle. So here's our rectangle. We're told that it's 3 meters longer than it is wide. We don't know the exact length of either of those, so let's just throw in a variable. So this is the width, this is the length. We don't know what either one is, but we know that the length is 3 meters longer. So let's just say our width is x, which means therefore our length is going to be x plus 3. So we are asked to find how much decorative fencing is needed to enclose the garden. So how much fencing is needed to go all the way around the garden? If we think about that, that's just asking us to find the perimeter of this rectangle. So once we know what x is, we can pretty easily find the perimeter of this rectangle. But in order to do that, we need to do a little bit more work. So the perimeter is what we're wanting to find. Let's look at the problem and see what other information we've been given. We're also told that its area is 54 square meters. We know how to find the area of a rectangle. We're going to take the product of its two dimensions. So with that information, we're pretty sure that we can solve for x. So the area of this rectangle is going to be x times x plus 3. But we're told in the problem that's going to be 54. So x times x plus 3 equals 54. We multiply everything out. X squared plus 3x equals 54. Look at that. That's pretty close to our quadratic equations that we were just working with. We need to move this constant over to the left-hand side, though. When we are working with quadratic equations, so again, our variable powers are 1 and 2. We want to get everything all together on the left-hand side. So if we move that 54 to the left-hand side, our equation becomes x squared plus 3x minus 54 equals 0. So this is now exactly like one of our drill problems. So we want to find two numbers whose product is 54 and whose difference is 3. Two numbers, product is 54, difference is 3. 9 and 6 seem to fit the bill. So let's write x something 9. We'll deal with the signs in just a second. And x something 6. So remember, we want the bigger number to have the same sign as what we see right here. So we're going to want x plus 9 and x minus 6. So in order for the product of these two things to equal 0, one of them individually has to equal 0. So either x plus 9 equals 0 or x minus 6 equals 0. So x equals negative 9 or x equals 6. Well, in the context of this problem, that doesn't make too much sense. Very rarely. All right, never. We never see a garden with negative dimensions. So this doesn't make sense in the context of this problem. So our x is going to have to be 6 here. Now be careful. X equals 6 is not our solution. Always make sure that you answer the problem. We are asked how much decorative fencing is needed to enclose the garden. We said before that's the perimeter. So the perimeter is going to be 2 times the width plus 2 times the length. We just found that x is 6, so our width is 6, and our length is 9. So 2 times 6 plus 2 times 9, that is 12 plus 18. So that's going to be, let's see here, 20, 30. So our final answer is 30 meters. In order to enclose our little garden, we need 30 meters of decorative fencing.